Hello, this is Professor Dan Kernler again with another video in my statistics series. In this one, we look at comparing two populations, but looking at the means. Okay, let's get to it. So if you've been following this series, you know we've done a wide variety of hypothesis testing. We've looked at a sample proportion compared to a population, a sample mean, a sample variance compared to a population, and then we recently in the last video looked at comparing two population proportions. But what if we have a mean and we want to compare the mean between two populations? So for example, we have this lesbian, gay, bisexual life and health database. I'll put that link in the description. And we wonder, do men realize their sexual orientation at a different age from women? Now we have the sample data here. You can see that it's 15.2 for men and 17 for women. So at the sample level, they're certainly different, but this is sample. Maybe that difference really won't end up being statistically significant. So we want to test that. We need to talk about then the difference between two population means. mu1 minus mu2. The sample level would be x bar 1 minus x bar 2. And this is not going to be shocking, but under certain conditions, that will be approximately normally distributed, with the mean being the difference between the population means. And then the standard deviation, it looks a little crazy here, but if you'll notice inside that square root, it's really the sum of two variances. And so in fact, if you have the sum or difference of two variables, the variance of that will be the sum of the two variances. So this would be the standard deviation of that difference between the two sample means. So again, the distribution of our difference between two sample means. A lot of words here, but basically if you have two samples taken from two populations, each population has its mean and standard deviation, then if the two populations are normally distributed, or your sample size is sufficiently large for each, about 30. And again, we've talked about this before. That's not a hard line, but that's a good kind of minimum level. Then this t statistic here, the value minus its mean over its standard deviation, this will approximately follow the t distribution with, and you can see the degrees of freedom there. That's going to be our test statistic for this hypothesis test. Okay, so for our particular one, we have to check, are the two populations normally distributed, or do we have sufficiently large sample size? Well, the age realized variable, it doesn't really matter here because we have very large sample sizes. So we can do this hypothesis test. You know the process. We have to define a null hypothesis, in this case, that the average age that they realize it is the same for both men and women. And then our alternative would be that it's not equal to. Our level of significance, alpha, we'll use our standard 0.05. The test statistic, that's this t, and we're not going to bother computing this by hand. We're just going to do this in StatCrunch. So in StatCrunch, this is under the stats menu, T-stats, it's a T. We want two sample this time though, and we do have with data. Now, both of them are under the age realized column. So we're going to do age realized, and we're going to use the where box to specify. So for the first one, we want to specify where gender equals man. And then for the second one, again, age realized, we want to specify where gender equals woman. And then we're going to leave off the pooled here. We'll talk about that in a second. And then we're going to just do a hypothesis test. Equal to 0 for the difference would be the null, and then not equal to, because we're just wondering if there was a difference in the age for the alternative. We'll hit compute, and then we get our statistic. So our t-value here is negative 5.14. The p-value, very small, less than 0.001. So our decision then would be to reject the null hypothesis. And therefore our conclusion then is that there is enough evidence to say that the age is different for men and women. The age that they realize their sexual orientation on average is different. Just like with proportions, we can try to answer this question with confidence intervals as well. So remember, confidence intervals for means and proportions, you have an estimate in the middle, and then there's this plus or minus margin of error. For a one sample mean, you have x bar plus or minus. Normally it would be z sigma x bar, but then we convert it to a t. We've done that discussion in that variable or in that video before. For two sample means, we have the difference between the sample means, and then we have this t times the standard deviation of the difference between the sample means. Now the difference between the sample the difference between the population means has this standard deviation. So at the sample level, we would have S's in there instead of sigmas. Okay, let's try to build this one by hand. You can absolutely do this in StatCrunch. It's just options edit from the previous one. And instead of a hypothesis test, it's a confidence interval. But let's show how we can do that here. Pull in all these values into the formula. We do need a t. We can do this with a calculator. We've done this before in StatCrunch. In this case, because the sample sizes are so large, it actually ends up being the same as if it was a z. So that's 1.96. Simplify, we get negative 1.8 plus or minus a margin of error of 0.07. Okay, let me try to help you understand with a visual about what this means. So we have this average age that the individual realized their sexual orientation. For men at the sample level, it was 15.2. For women, it was 17. So it's important here that we are defining X bar 1, that first one, to be men. This is not important that it's men or women first. We can put either one, but it changes our interpretation. So you'll see here that we have a negative 1.8. That's because the average for men was less than women. So because we put men, remember it was gender equals men for the first one, gender equals man, for the first one. So we have a negative. So it's negative 1.8. Men on average realized the sexual orientation 1.8 years before women. But our confidence interval says it could be as little as negative 1.1 or as high as negative 2.5, as high in absolute value here, of course, not in sign. So either way, though, clearly, even at this negative 1.1, men realized their sexual orientation before women. Now, a little note on pooled t-tests. This is a little theoretical, just kind of for completeness sakes. So we had this distribution here, this t-value that approximately follows the t distribution. It doesn't assume that the population variances are equal. Now, we could assume the population variances are equal, and then you can create this statistic, pool the variances together, and this one exactly follows the t distribution. Okay, so approximately versus exactly. Well, why not just assume the variances are equal? This is actually a later test. The problem is we'd have to do that test first, and that test is really strict. The two populations have to be normally distributed to do that test. And if they're not, then you can't even do that test. So most statisticians just recommend avoiding the test of equal variances and just compare the means, assuming that the variances are not equal. Okay, so far we've been comparing two populations. We compared men to women. What if instead we had like a father and a mother and they were paired together? And maybe we looked at like the age difference or the difference in their socioeconomic income, or index, I should say. Well, that's not two independent samples then. They're matched up together. That's a different analysis. So we need some more machinery for this case. In this case, what we're going to do is instead of comparing independent populations, we're going to call these paired populations. They're dependent. They're paired together. And the analysis is different. What we do is we analyze the difference. So in this case, we might set up, say, father's age minus mother's age. And that order is important. And say we wonder, fathers are probably on average older. So we wonder, is that average difference positive? Right? That would mean on average fathers are older. So let's talk about the distribution for the mean difference. At the sample level, we'll call it D bar, the average difference. This is going to shock you, but under certain conditions, that average difference is approximately normally distributed, where the mean average difference will be the same as the population average difference. And the standard deviation is the standard deviation over the square root of n. So this should look kind of familiar. There's a lot of funky subscripts here, but it's the standard deviation over the square root of n. So for the distribution of the mean difference, the sample mean difference, if we have these things true, if it's a sample is obtained using simple random sampling, the sample data are in matched pairs, and there's no outliers, and it's either from a normally distributed population or a large sample size, there's our 30 again, then we have this t statistic, and that it follows the t distribution. And that's going to be our test statistic for this hypothesis test. So let's look at this difference between the father and mother and look at the age difference. We'll define D, the difference, to be the father's age minus the mother's age. And that's really important because that changes how we interpret the answer. You can choose either order here when you're setting this up, but then you got to pay attention to the order when you interpret it at the end. And I'll explain what I mean when we get there. So let's do a hypothesis test. Null and alternative, our null is that the average difference is 0. They're the same age. And then our alternative, this is where it's important, we wondered if fathers were older. So that means we wonder, is the mean difference positive? Alpha here, let's use our standard 0.05. The test statistic is d bar minus mu d over sd over square root of n. We're going to use StatCrunch for that. In StatCrunch, this is t-stats again, but now we're going to choose paired with data. And then in this case, we have the first column will be father's age, and then the second column will be mother's age. And then our null hypothesis is that the mean difference is 0. Again, alternative is that it is greater than 0. So we calculate a t-statistic very large here, 32.3. Our p-value less than 0.0001. So our decision here will be to reject the null hypothesis. In our conclusion, there is enough evidence to say that on average, the immigrant fathers are older than immigrant mothers, right? Because we got a positive difference. That's what I mean about clearly defining your difference so you know how to interpret and state this conclusion correctly here. Just like with comparing independent populations, we can do this same analysis with confidence intervals. So remember the confidence intervals, there's a point estimate in the middle, there's plus or minus some margin of error. So for a one sample mean, you have x bar plus or minus t times the standard deviation. And so for two sample paired, it's the same idea. It's the mean difference plus or minus a t times the standard deviation of the mean difference. And in that case, that's going to be the standard deviation of the differences over the square root of n. In StatCrunch, I'm not going to record this, but it's the same process. You just go options, edit to the previous output if you want to, and just choose a confidence interval instead of a hypothesis test. And here's the output. So we have a mean difference, d bar is 3.3. So on average, the difference between father's and mother's age is 3.3 years. So on average, fathers were 3.3 years older than mothers. For the confidence interval, well, it could be as low as 3.1 or as high as 3.5. So again, we have to care. The order is important. We actually think the father is older than the mother. It's 3.3 on average, but it could be as high, as little as 3.1 or as high as 3.5. Either way, fathers on average are clearly older than mothers for this children of immigrants. All right, I'm a little worried that this was a really heavy video. I hope it was helpful and it helped you understand comparing two population means, or when they're paired, comparing the mean difference. But that's it for this video. If you want to see more of these, you can subscribe, hit the bell to get notified when more of these come out. As always, thank you to the Elgin Community College Board of Trustees for approving my sabbatical during the spring 2021 semester. That's the only way I had time to record and edit, produce, upload all of these for you. Thank you so much for watching, and I'll see you in the next one.